I'll be discussing and showing outgassing with the different viscosity fluids. So with outgassing, you can typically get bubbly flow, annular flow, or churn slash slug flow. So with bubbly flow, typically this is when it's mainly dominated by the magma, and the bubbles flow individually throughout the column. This then, with increased gas flux, you can turn it into a slug flow, which is where the bubbles nucleate together and form one large mass moving up. And this also produces daughter bubbles, which I will explain further in the video when I just show you. And then this can be turned into annular flow with higher gas flux, which is when the column is dominated by gas itself, and the walls have some magma on them, but the majority of the internal conduit is bubbles releasing. So I will be using a 12 milliliter syringe to demonstrate this. So in bubbly flow is typically the most common. I will show that in the water, hopefully. So as I release bubbles, you can see that they are individually releasing. This is kind of a limitation because they don't actually form this way. They will nucleate instead. As you can see, it moves slightly faster within the oil. And then I will also show, so with increased viscosity, it's a little harder for the bubbles to flow through, and it's also easier for stiffening to occur, which increases your possibility for slug flow and annular flow as well. And then here I'll try and show slug flow, where I will just inject the entire 12 milliliter syringe. It would have been hard there. I can't slow it down, unfortunately. There you would have seen some bubbles flowing from the bottom. Those are daughter flow bubbles, so there'll be one large bubble that nucleates as it ascends up the magma chamber. This will then, as so with the slugs, you could see that there was bubbles coming below. Those are called daughter bubbles. These form because of the different viscosities of the magma. The turbulence of them cuts the lower bubbles, or sometimes even the upper part of the bubble, off, causing a trail. This commonly happens with higher gas influx, going towards a churn flow, which is in between a slug flow and an annular flow. Unfortunately here I'm not able to show an annular flow. With that, I would need a consistent pump in order to make it so that the majority of it is gas, not liquid, and it would also make a large mess with the small container that we have. But with annular flow, if I was to demonstrate it, you would put a pump in, for example, and have it running consistently for a while, and the entire column should end up as bubbles, as you saw with the bubbly system, but it would be the entire thing, and then the walls of the container might still have magma on them because the magma has to move out of the way.